So, hello everyone. I'm Harish, and here I'm here to teach you some good questions, crazy questions of JEE mains plus advanced. I like to solve questions, so I came here to share some knowledge about solving questions so that it makes some good amount of practice for me. Plus, it helps you in either way. I don't know how. Maybe it helps you to motivate you, or it helps you think better on questions. So I just introduce myself. I am Harish. I'm Harish R, and I'm not from any IIT, or I'm not from any NIT. I was just a drop. Uh, yeah. Okay. Never make sense of this word. Okay, because many will now think that he's a dropper, so no use of him, no use of learning with him, right? No, I can teach questions in a good way. Just took a drop because of I haven't focused here. So from now I'm going to focus here. So just solve let's solve some good amount of questions and just educate together. And let's say the pattern of videos and how my video is going to be there. It's just I'm going to post videos daily by solving some good amount of questions, not depend on the number, maybe 5, maybe 10. If and the time passes, I'll try to solve some advanced questions. First, today I come up with some good basic questions from laws of motion, physics. Not very tough questions, not a very easy questions, basic questions that can clear you concepts. My teaching, I solve questions by recalling the concepts. So I try to teach in that way so that we'll recall the concepts together and solve the questions and use those concepts in the questions. And today I come up with lots of questions of Newton's second law. It's all about momentum that we're going to deal today. So don't worry, it's going to be chill. Then let's start solving the questions. Why are we wasting time? Okay. Okay, that's all. Okay. Let's all solve the question. So always when you see a question, let's have an observation on it. I mean, write what you can take from this question. Just mark. So the question says that, let me take a highlighter. The question says that, oh, the size of highlight is very big. Is this okay? Okay. So the question is that a stone of mass 1 kg. So the mass of the stone is given. Okay, and also never mind about my handwriting because I was using a stylus pen which costs about 250, and I was using a tablet that is made a basic level. So my handwriting was not that so good. Just listen to my words, what I was saying, and grab the things and knowledge. So stone of mass 1 kg is thrown with a velocity of 20 meters per second. So they give you the velocity of 20 meters per second across the frozen surface of a lake, and it comes to rest after traveling a distance of 50 meters. I was like to just mark the numbers. What is the magnitude of the force opposing the motion of the stone? What is the magnitude of the force opposing the motion of the stone? Nice. So I guess many of you will get the scenario because this is not that so tough. It's a cool stuff. So many of you may get the scenario. Okay, let's go to the question. So what is given in the question? A stone of mass 1 kg is thrown with a velocity of 20 meters per second. So just imagine this as a lake. So if this was a lake, so if this is a lake, so there's a lake which is frozen, and a stone of mass 1 kg is thrown with a velocity of 20 meters per second. Uh, the velocity of 20 meter per second. So since it is a frozen lake, since it is a frozen lake, it travels like this. Am I right? Since it is a frozen lake, it tends to travels like this. So if this is the lake, this is the lake. Since it was frozen, I'll draw the stone in this way. Like the stone, if this is the stone, it travels in this way. with a speed of 20 meter per second and it weighs 1 kg. Okay, nice. Until now, the question was nice. So, what's asked in the question? And it comes to rest after traveling a distance of 50 meters. So, after traveling a distance of 50 meter, the stones come to rest means its velocity is 0 meter per second at the point when it is 50 meter. Okay, nice. Cool, cool, cool. Well, we understand the question. Means we now understand what's the question, given the questions. Now let's understand what's the actual question. They ask about what is the magnitude of force opposing the motion of the stone. Okay, they're asking the magnitude of force opposing the force of motion. Nice. So to conclude about that, first let's figure out the acceleration because they have given us the force. They want us to find the force, not given, they want us to find the force. So according to the formula, what is force? Force is equal to mass into acceleration. I have the mass, but I don't have the acceleration. Oh, sorry, but I don't have the, what is that? Acceleration. What is acceleration? I don't have that. So just find what is acceleration. To find what is acceleration, Newton given us some way to do that. What is that? Yes, Newton's law. Use Newton's law. Just think about which law connects that. Which law connects Newton? I mean velocity, initial velocity, final velocity, acceleration. Because I know what is initial velocity. What is initial velocity? That is u, which is 20 meter per second. Some can come on say what is final velocity? Yeah, final velocity is 0 meter per second. Why? Because it came to rest after traveling a distance of 50 meter. It has come to a rest. So final velocity is 0, and in this course of time, it traveled a distance of what? 50 meters. Yeah, the question now become easy. So you just use which equation? S equal to ut plus half it. No, v square minus u square. V square minus u square is equal to 2as. Just want what a. So just substitute. V is 0. U is 20, so 400 means 20 square is 400. I don't want to spoon feed you guys. 2a, this is 50. 50 into 200, so this is 4. So a is equal to minus 4 meter per second square. Okay, I found out that a is minus 4 meter per second square, but what is that minus it is? Yeah, now we are getting some good amount of knowledge. The minus 4, mean the minus in this question indicates that it opposes it opposes what? It opposes the motion. Simple. Am I right or wrong? Yeah, because it is acting on a negative direction. It means it is acting opposite to the motion. Acceleration is acting opposite to the motion. It means that it is decelerating. Only when it decelerates, only when it decelerates, the motion is stopped. So we got a correct answer that the answer is negative. It means the acceleration has become now deceleration. So the particle is going to stop at some course of time. So what is the force that is required? Now, what is force that is required? Mass into acceleration. Mass is given as 1 kg, acceleration is 4 meter per second, that is what? 4 Newton. Wait, the mass is 1 kg, right? So the last, what is the magnitude of force opposite to the motion to the stone? Okay, yeah, correct. So this 4 Newton, perfectly all right. That is 4 Newton, perfectly all right. I guess you guys got the question answers right. It was not that so tough. I just want some basic questions to take so that it makes us clear the concepts. Nothing complicated. Okay. So I guess it's clear. So let's clear this out. Alrighty. Let me clear this already. And oh, can I able to clear this? Okay, super. So next, let me add the next question. Don't. What's the next question? Okay, let's take this question. Nice. Okay. Okay. A variable force acts on a body of mass 2 kg initially at rest as shown in the figure. Okay. Calculate the impulse of the force in first 2 seconds and speed of the body after 2 seconds. Okay. They ask us to calculate the force impulse in first 2 seconds and speed after 2 seconds. Okay, I guess this is going to be an easy question. If you are aware about the things, see, if this is a graph between force and time, then area under the graph is what? What is the area under this graph? What does this area under the graph indicates? As you are aware about solving, as you guys are in a question solving stage, you guys have to know about this. This is force. This is force. This is time. What is area under the graph? That is force into time. What is force into time? FDT. What is that? Okay. Oh. You guys are thinking? Okay, let you guys think. That's nothing but the impulse. So area under the graph just says the impulse of the motion. So this area is the impulse. But wait. Sorry. That is not that area. This is, area is not that. The area is this area. Yeah, the one I'm marking because they are given us the dot lines. So it is a trap for somebody, not for everybody. Not for everyone, it's just for someone. So what is the area under the graph? So that's easy to calculate, right? Area under the graph, let's name this A. Okay, A and B. So area of this triangle is a right angle triangle. So half into base into height, half into what is the base, which is 2, height is 10. To cancel, which is 10 Newton second is impulse. Then they ask, so this part of the question was crystal clear. This part of the question was crystal clear. What about this? What about this one? Speed of the body after 2 seconds. They ask speed of the body after 2 seconds. It's quite easy. What is change in momentum? Change in momentum is impulse. So we know the impulse. Okay. So we know the impulse, which is 10 Newton second. So if impulse is known, just give me a minute. I do have some notes to tell you so that I can tell you. Just give me a minute. I was searching for my note because I took some good notes, so it helps in our question always. It's a good question. So the impulse equals to 10 Newton second that we have found out. Okay. As I have said, 10 Newton per second is change in momentum, which is m delta v. What is m? Is it mass given for 2 kg? Yes, super. The question is very easy. So the mass is given as 2 kg. Change in velocity is del v. This is 5. So change in velocity is 5 meter per second. What does that 10 means? Bro, initially it is at rest. Variable first action about you initially at rest. So even more good the question becomes because del V is equal to V final minus V initial. So finally it was some VF. Initially it was 0. Why not del V? So the final velocity is 5 meter per second. How cool this question. It's completely conceptual based. No one can solve this question just by just by knowing the formula. Bro, I know the formula of impulse. I know the formula of momentum. I know the formula of force. Never, nah. You know the concept of graphs. If this was the graph, then this area could have what? Vanished. If this was the graph. Okay? It's completely a good question according to me. So next I'm going to hit you with very good questions. Next I'm going to hit you with very good questions. The third question that I'm going to take is, wait a minute, I was searching for the question. Is this? Yeah. Now let's go to the question. It's a very good question. The block of mass 5 kg is moving with the speed of 8 meters per second. Okay, just imagine the case, a block of mass. So just imagine the case, a block of mass 5 kg moving with speed of 8 meter per second. Sorry for the inconvenience happened in between the writings. It's not my fault, it's my pen fault. Sorry. A force of 10 Newton is applied on it for 3 seconds. Oh my god, so I want to make more try some more. So block, I'm not getting any shapes here. Why don't I get that? A block is 5 kg. Oh, nice. It's moving with the speed of what? 8 meter per second. Nice. Now a force of 10 Newton is applied on it for 3 seconds. But they haven't given the direction of force. It is along or opposite, because if the block is at rest, I can say that I can make anywhere the force the force was acted, but the block was not at the rest. It was moving at the speed of 8 meters per second, guys. So the direction of force is more important to me. So let me read the question completely and come to a conclusion. Find the final speed of the block if the force is applied. Yes, see, they got some conditions for us along the motion. So in this first case, the force is along the motion, which is 10 Newton. Okay. Second case, let me mark in red. Second case, let me mark in red. It is opposite to the motion. F dash. In third case, let me have a blue color. What is that? That case is normal to the initial direction of the motion. Okay. It means that the force is acting kind of this way. I mean normal. Or this way, upwards. Anyway, okay, let's go to the question. Okay, let's find out the first case. So let's find out the answer for the first case. Okay, the first case, what does the first case says? See? Okay, the block is moving with the speed of 8 meters per second. A force of 10 Newton is applied on for 3 seconds. A force of 10 Newton is applied on for 3 seconds. So I can infer acceleration. Acceleration is force. I can take the acceleration. Force is equal to mass into acceleration. So acceleration is equal to force by mass. Force is 10 Newton and mass is 5 kg. 5 kg, that's 2. So acceleration is 2 meters per second square. Okay, cool. So acceleration block is 2 meters per second square. First, the velocity of the block is 8 meters per second. Okay. So what should I, what, if it is along the motion, what is the speed of the along the motion? Find the spinal block if the force is applied. Find the final speed if the force is applied along. Okay, let me, I don't have final velocity, so I mean I want to find final velocity. Just used, so like v is equal to u plus ad. Yeah, nice equation, I can use that. Means now let's use v is equal to u plus at. I want to find v. U, that is 8 meter per second, that is given. Acceleration is 2, time is 3 seconds, which is 8 plus 5, 6, which is 14 meter per second. Cool buddy, cool buddy, cool. We got the easiest way to solve this question. But wait, this is twist waiting for you. Final question, I mean final part. Second part is also doable, I guess. Second part is also very doable, I guess, right? It is the force acts opposite to the direction. The force acts opposite, right? So acceleration is minus 2 meter per second square in this case. Use this to find. Let's use this to find acceleration. So v is equal to u plus at, same equation. V is equal to 8 plus minus 2 into 3, which is 8 minus 6, which is 2 meters per second. Absolutely fine, brother. Now let's move to the third case of the question. The third case is something a very good question. Third case is something that is very good. Why am I saying very good? Because you need some knowledge about vectors. See, the block, let's say the block is moving with an initial velocity of 8 meters per second in this way. Question says that the third part says that normal to the initial direction of the motion. So if I take this as my initial direction of the motion, the normal to that was what? This direction or this direction. So for convenience, I just take this direction. Of what direction is normal. So what is the direction of this one? So if this, what is this? This is u, means initial velocity. Okay guys, now the force is acted in this direction, right? So what is this one? This arrow indicates what? Force is a since vector quantity. Force is equal to mass into acceleration. That's it. So this is the direction of acceleration. So to be more precise and clear, let's draw another diagram. This is the direction of what? Initial velocity, which is in direction of I cap. Then this is the direction of acceleration, which is in the direction of j cap. So clear. Nice. Next thing. Let's move to the next part. Easy. We come up. So I know v is equal to u, which is in the direction of I cap, plus a, which is in the direction of j cap, into t. Nice. I got the perfect answer. I got the perfect equation. That is all need for this question. That's it. See, now your job is to, okay, just now what you do next, you substitute the values. What is u? 8 I cap. What is a? 2 j cap t. Brother, now I don't want the direction of velocity. I don't want the direction of this velocity, final velocity. I just want the magnitude. What is the magnitude of v? What do you guys do? Bro, it's the basics of vectors. I don't want you to say. It's easier, bro. Just take the under root squares, 8 square plus 2 square. Just take the components into attack and you'll get 64 plus 2. No, you missed the time to substitute. So this is 6 square, so this is 36 because we missed the time, which is equal to 6 j cap. Okay, that's it. Okay, then that is root 100. Finally it is 10 meter per second. Nice. Is it a good question or not? Is it a good question or not? Don't ever blame the video about the pen condition, my writing style. No, bro, if you are really concerned about that, then just quit your JE preparation, please. Just focus on the question, take your note, try to solve it. If you couldn't find the answer, then pause my video and watch what's the solution. Instead of that, you're blaming in the comments. Don't comment in the comments that the pen quality was bad, his voice quality was bad, the screen quality was bad. Bro, you're bad. Just get out of the session. I want people who are really concerned about the preparation, who are really concerned about question solving. You can understand what even I read. You can understand what thing I read. That's it. That is something that I want. I guess I don't want to explain this question again because this is an easy question. So let's move to the next question. I don't want to make this video more big. Okay, the next last question coming to you. This is something that is a graph based. That's not big tough. So let's read the question. Okay, the same horizontal, I have already marked the answer. It's okay, I'll teach you what is the same horizontal force is applied to the object of different mass. Which of the following graphs illustrates the experimental results? And the graph is between acceleration and mass. Every graph is between acceleration and mass. Okay, the question given that the condition that is given is same horizontal force is applied to different mass. This is okay. So this statement makes the question complete. That's it. Nothing to go away, brother. Just write the equation of mass. Force. What is force? Force is equal to mass into acceleration such that it is given force is constant. Why? Because it is applied in an equal amount to every object that has different mass. So force is a constant. So just avoid force now. If force is a constant, then what is the relation between mass and acceleration? If force is constant, mass and acceleration, so mass is equal to k by a. Since k is a constant or force is a constant, I get a relation in this equation that mass is inversely proportional to acceleration. That's it. Why don't you think the question got completed? Now let's go to the graphs and just infer what other graphs that is given. First option D. Let's arrive at option D. So it's a straight line graph. It means that direct proportional. A is directly proportional to M. That is not our case. So 3. In this case, they are given that A is constant. No. Oh, it is given that same. That is same, right? So if you want to make this clear, just point some point. You take this point and make a line like this. See, it also same. When mass is increasing, graph or decreasing. But see this graph, when mass is higher, the acceleration is low. When the acceleration is higher, the mass is low. So option A is the correct answer for this question. Kudos to everyone. who made this question easier. I don't want you guys to spoon feed. Again, I'm saying I don't want you guys to spoon feed. Just understand the concept. I cleared you the concept why how the graph looks like. I cleared you the equation A is indirectly proportional to M. Then at the very next second, your mind thinks that it's a decreasing graph because it is as universal proportional. But what just you don't want to look at the options, bloody fool. You just go into the graphs. That makes sense. Okay. So next question and the last question of today's class. Four students perform an experiment by pulling an object. Four students perform an experiment by pulling an object horizontally across frictionless table. They repeat the experiment on several other objects of different mass, applying this enough force to produce the acceleration. All of them graph. So this graph is simple. The graph is FOO. The graph is between what? Force is equal to mass into acceleration. The graph is between force and mass. So force is directly proportional to mass. Which graph suits that? It's a decreasing graph, no. It's a constant graph, no. It's a decreasing graph, no. Yes, this one. That's it. What is this graph? This is a straight line graph. That's it. So let me end this video with a good note that I have already told in my it is already in my profile, which is that slow progress is still a progress. Still a progress. So stick to the plan. Never ever change your plan. Accordingly, just go with the flow. You will succeed. And let's have a really good session about with some good questions that I had solved on that day. I never took questions from I never take questions from anywhere. I solve those questions. If I tried hard and solved the question, I'll take up to you. I took some easy questions today because I just want to make you clear about the concept. So first, let's go with some easy good questions. Then we'll start to solve some advanced level questions. I'll mention those advanced level questions. What are those questions? Is this question from mains level, or is this question from advanced level? Is this question from a beginner level? I guess at the start we have some beginner level questions, but at the end of the class we have some good amount of mains level questions. Okay, so let's have this fun classes every day. Thank you.